QuadQuiz!
Brought to you by Math with Sir Lester. There are 3 questions for this video, and you are to answer them in 15 seconds each. Are you ready? In 3, 2, 1. Let's consider this quadratic equation. First question, is this trinomial factorable? Yes or no? The answer is no. Next question. What should be the constant to be added on both sides for the completing the square process? The constant should be 25/4. Now, what are the roots of the given quadratic equation? The 2 roots are positive and negative square root of 17 plus 5 all over 2. Did you get 3/3? If not, please continue viewing this video. To solve for the roots of this given equation, we need to understand the correct process. Now, we are again not using the quadratic formula yet, so that we could actually practice a specific process in order for us to solve for the roots of equations just like this. So we can identify the process, of course. First, we cannot use extracting square roots because there is a b coefficient. We cannot also use the common minimal factoring because there is a c coefficient. And by the way, the coefficients are a is 2, your b coefficient is a coefficient of your x, that's -10, and your c coefficient is your constant 4. Now we are left with 2 other methods. It's either factoring or completing the square method. We can determine if this is factorable and hence use factoring using AC way. AC means we multiply the coefficients a and c, and we look for the factors of 8, which may be added to result to your b coefficient -10. But the factors of 8 are 1, 8, we also have 2, 4, and the negatives, -1, -8, we also have -2, and -4. Now looking at these pairs, and if we add all of them, the closest is this pair here, -1 and -8. For -1 times -8 is +8, and their sum is -9, but it's not -10. Hence, none of these 4 could satisfy the process of identifying whether the given trinomial is factorable or not. This would mean it's not factorable, and we use the remaining method, the completing the square method. The completing the square method allows us to pick appropriate value for the constant. It's the constant that we are going to change. So instead of 4 in the given, we look for a specific constant which could make the trinomial factorable in terms of a perfect square trinomial. We need to do that by first. Okay, we'll have 2x squared minus 10x plus 4. We can do that by, again, moving out this constant because that's not the constant we need. 2x squared minus 10x and is equal to -4. We need to look for an appropriate constant to be used for this side here to be a perfect square trinomial and hence factorable later. But we have a process that will make it even easier. Not actually easier, but less complicated. Let's divide all terms by 2 because it's the coefficient of a. If this is 5, then we divide all terms by 5. We just need to come up with an expression where our new a is 1 so that it's easier for us to complete this square. This would mean the second term is minus 5x because that's 10 divided by 2. And your right-hand side is just negative 2. Okay? So we need to look for an appropriate C. Let's label it C. And we are going to use the new A and B coefficients here in this formula. B, by the way, this B here is not the original B, but the new B, all over 2, and then square root of A. Now, sometimes this square root of A may be a skip for our A here is already 1, but I'm just placing it there for a more appropriate process. So the appropriate C we need for both sides is when we have negative 5 over 2, we get divide that one, times square root of 1, and then use square. So the square of negative 5 is positive 25. The square of 2 is 4. Before we continue, we need to embrace that not all results would lead to, for this C, not all results will lead to an integral answer. We also accept fractional results since they are also real numbers. And this is probably where some processes might get trickier, but we have this video for you to be guided. So we have x squared minus 5x, and we will add 25 over 4. And by the way, your hint in the area where you will get a C which is non-integral is your B coefficient is odd number. Sorry. If it's even, then we expect integral results for our C needed for this to become a perfect square trinomial. And this is actually a perfect square trinomial already. But don't forget to do the same thing on the other side. So you have 25 over 4. Now, we are sure that for this to be a perfect square trinomial because of this process. So we now can express it as a square of a binomial by squaring the first term, x. Square root of the first term rather, x. Square root of the third term, square root of 25 is 5, square root of 4 is 2. And we use the sign here of this second term. And if you're not convinced with that, you could always check this. Apply FOIL method to 2 sets of binomial with this expression. So for the right hand side, we just need to add this. Take note that negative 2 can be expressed as negative 8 over 4 with the same denominator. So you will have 25 minus 8, you will get 17 rather. 17 over 4. Now after this, since we have a square of binomial, let's take the square root of both sides. We take the root of this. Don't forget the plus minus notations. So you'll have x minus 5 halves is equal to positive negative square root of 17. Let me separate this over square root of 4. Take note that when we separate the radical expression, the purpose of this is looking at the denominator, which is 4, can be already simplified. So we have x minus 5 halves is just equal to plus minus square root of 17 all over 2. And when we try to add both sides by 5 halves, you'll have plus minus square root of 17 over 2 plus 5 halves. These are now the 2 roots of the given equation. The first root is when we use the positive square root of 17. And since they are similar fractions, so let's try to combine them. 5 all over 2. And the second root is the negative of that. Negative square root of 17 plus your 5 all over 2. So these are now the 2 roots of this given equation. And we have solved it using completing the square method and applying the rules of radical expressions. And again, I believe that the topic on radical expressions should always start before quadratic equation in order for us to understand this further. And this is for QuadQuiz! Subscribe now!